Okay, so we continue to look at solving quadratic equations today, but this time they're going to be equations which we cannot simply solve by rearrangement, which is what we looked at in the previous video. And so we want to look at our first option. If we can't solve by rearrangement, our first option is if we can solve by rearrangement, we do that. Our next choice is if we can use the null factor law, which we'll talk about in a minute, we want to use that. Then after that, we'll look at two other options that we can go to if these first two options fail. But these are the simplest options, and so therefore we consider them first. If we can do it this way, it's the easiest way, let's do it. Okay, that is by rearrangement. Then the easiest way is to use the null factor law. We'll do that if we can, but if we can't, then we've got other more complicated ways. Okay, so as I said, equation that can't be solved by rearrangement, more than one term involving x, probably has 2 or 3 terms in the equation, then we're going to need to use the null factor law. Now, the null factor law is a really important thing, and I'm really going to be quite strict with you about please make sure that what you write down reflects the fact that you are using the null factor law. Lots of you will leave out the equals 0 part of the equation. It's really important. The minute you don't write that, you don't have an equation. Something that isn't an equation can't possibly have solutions. So it's really important that you're writing out the right things here. The null factor law also extends beyond quadratic equations. It's actually relevant in all sorts of other equations down the track. So it's important that you actually keep track of what it is that you're doing so that when we get to more complicated equations in the next couple of years where you might need to use it, you understand what it is so it can be applied in those situations. It's very easy to start to take shortcuts with the null factor law and just think, you know, we'll see how it works, but just think, oh, I just take the negative of that number and I get the answer. Try and keep clear about what it is that you're actually doing in your head. Okay, so the null factor law is all about if I have two things that multiply together to equal 0, so a times b equal to 0. If I know that a times b equals 0, the only way that that can happen is if a equals 0 or if b equals 0. Now in maths, when we write the word or, we technically mean and or. It's called an inclusive or. And whenever we use the word or in maths, we mean and or. So A or B could equal 0. And so we want to make use of this fact to solve a quadratic equation. Okay, so it relies on us having a product of 2 or more things, because actually the null factor law can be extended. If I know that 3 things multiply together to give me 0, that also tells me that A equals 0, or B equals 0, or C equals 0. So if I have a product of 2 or more things, so 2 or more things multiplying together, and they are equal to 0, I can utilise the null factor law. And so therefore we need to create that situation first. So we need to first of all rearrange so that one side of the equation is equal to 0. Okay? Because if I know that A times B equals 8, it doesn't tell me anything about A and B. Okay? A could be 2 and B could be 4. A could be negative 2 and B could be negative 4. A could be 1 and B could be 8. A could be root 2 and B could be 8 on root 2. Okay? So there's infinitely many things that could happen here. It's not just, so it's unhelpful. The only way it's helpful is if 2 things multiply together to equal 0. So the first step has got to be to make one side of your equation equal to 0. That's step number 1. Then you want to factorize the other side of the equation, which if we're dealing with a quadratic equation will be a quadratic expression. So you want to factorize. And the process of factorization, remember, is all about taking something and rewriting it so it is a series of things being multiplied together. So we're going to have things multiplied together equal to 0, and then from there we'll be able to use the null factor law. Either that thing equals 0, or that thing equals 0, or that thing equals 0, and we can solve from there. Okay, so that's our strategy. So let's focus on that. Let's be clear about what we're doing. Let's make sure we actually write down the things that we need to write down. So solve each of the following. So step 1, make one side 0. That's already done. Step 2, factorize the other side. That's already done. So we already have 2 things multiplying here to equal 0. The only way that can happen is if that thing equals 0, or if that thing equals 0. And then now we have 2 simpler linear equations that we can solve. So if this equals 0, it means that x has to equal negative 3, or x equals positive 5. Now, it's really important that you use the word or, not and here. It's quite a technical mathematical thing, but it's not, yeah, and it comes down to sort of our definitions to do with sets. I don't think I'll get into it too much here, but it's really important that you don't write and, because x can't be both -3 and 5 at the same time. There are no numbers that are both those things. It's either going to be equal to -3 or it's going to be equal to 5. So use the word or just put a comma, or just write the two solutions, but do not write the word and in between them. Okay, part B. Step 1, make one side 0. That's already done. Step 2, we want to factorize the other side. So now we need to recall the factorization methods we've looked at in 3 earlier videos. Common factors, difference of 2 squares, perfect squares. Is it a simple monic quadratic? Is it a harder non-monic quadratic? Okay, what do we need to use? So in this case, when we've only got 2 terms, the first thing you're looking for is common factors. And if there aren't common factors, then you're probably looking for difference of 2 squares. So there is definitely a common factor here of x. So we factor out the x. Oops, sorry. And then we use our null factor law. So either x equals 0 or that bracket, x minus 6 must equal 0. Those are the two things that are multiplying together to equal 0. So one or other or both of them must be 0. X equals 0, therefore, is a solution to the equation. Solving this one gives us x equals 6. So there are 2 possible solutions to the equation. I want to be really clear about an incorrect solution method that students commonly use. Okay, so what's common is people go, oh, okay, well, if I added 6x to the other side, yep, oh, and then I'll divide by x, and so x equals 6. But actually, you lost a solution. There was 2 solutions, 0 and 6, and you've only got one of them, which is 6. Okay. Now what happened, in this process here, when you divided by x, you automatically assumed that x couldn't be equal to 0. Because if it was to equal 0, it's not possible to divide by it. Okay. So the problem is when you should never, ever, ever divide by x. Okay. That's the rule. Never divide by the unknown, because in doing so you assume it can't equal to 0, and that might actually be a solution. Okay, so this is not what we want to do. This is not the correct solution. Okay, we want to make sure that we make one side 0, factorize the other side, use the null factor law to solve. Okay, let's keep going. So part C, make one side 0, that's already done. Factorize the other side, we need to do that. It's a monic, simple quadratic, so we can straight away write down our factorization, because we know it'll just have single x's in each of the brackets. And we're looking for factors of 6 that add up to -5. So that will be -2 and -3. Now this is where I don't want you to lose this. Okay, it's really important. The only way that you can possibly solve this equation is A, if there is an equation. So if you don't have this written here, sorry, I just put my hand over the screen, you can't see me covering it up, but if you don't have this here, that's not an equation. There is no solution if there's not an equation, okay? Also, if it doesn't equal 0, the null factor law does not apply. The only way that this allows you to say, well, x minus 2 could equal 0, or x minus 3 could equal 0, and therefore x could equal 2, or x could equal 3, the only way you can do that is because it equals 0. Please don't lose that at that step, okay? It's really important. All right, part D. Now again, we might be tempted, like the do not do method up here, to divide both sides by, well, dividing by 3 is not a problem, because 3 can't ever equal 0, that's not an issue, but we certainly should never divide by x, and it might be tempting to do so here. So if you want, you can divide by 3 first and get rid of that common factor. So dividing both sides by 3 here, this is the same as x squared equals 5x. Sorry, just 5x. But we can't divide by x, okay? So then you want to get both terms on the one side. So that's 0, you've got 0 on one side. You want to factorize the other side. So you've now got 2 things multiplying together to equal 0. And then that tells us that either that thing must equal 0 or that thing must equal 0, so x must be equal to 5, and there are 2 possible solutions. Now I just want to be clear about the fact that if you didn't take out the 3 out first, that wouldn't be an issue. So 3x squared minus 15x equals 0. Common factors are 3x. And then you would simply get that 3x equals 0 or x minus 5 equals 0. If 3x equals 0, it means x equals 0 or x equals 5. So it doesn't matter if you don't take out that 3 at the start, divide away that 3 at the start, but it's perfectly okay to do so, and it sort of simplifies things earlier on. So again, it's about common factors, and if they're numeric common factors, when you have an equation, you can just divide both sides of the equation. Okay. In fact, I might make that point in this example here. So here, we've got a non-monic, we've got one side 0, but we've got a non-monic quadratic, so it's going to be a harder factorization. But I've got more flexibility here because what I have is an equation. So you could think about this in two different ways. I could think about adding each of these terms to the other side of the equation that ends up with 0 equals positive x squared plus x minus 12, and I now have one side equal to 0 and a non-monic quadratic on the other side, sorry, a monic quadratic, so a simple quadratic on the other side. Or you could think about it as multiplying both sides of the equation by -1. -1 times that and -1 times that gives me x squared plus x minus 12 equals 0. Now I want to be really clear, can we just go back to, if this was not an equation, if this question was factorize negative x squared minus x plus 12, you can't just get rid of the negative. You can't just say, oh, this is just the same as x squared plus x minus 12, and so therefore it's x plus, what will it be, 4x minus 3. These aren't the same thing. They're not equal anymore. You can't just multiply by -1 and expect it's the same thing. It's the same as you saying, oh, 3 equals -3. No, it doesn't. I just multiplied it by -1. Well, that means they're not equal anymore. So you can't, if there's not an equation, you can't lose that negative. You're just factoring it out, and it has to sit out the front there still. But because we've got equal to 0 on the other side, what we have done is multiply both sides of the equation by -1, and so therefore we can essentially get rid of that -1 that's in the way. Okay, but I want you to be really clear about the difference here. It's only because we've got one side equal to 0 that enables us to essentially cancel it out, because we've done the same thing to both sides of the equation. Okay, so now we have a monic or a simple quadratic. So we use our simple factorization method, just a single x in each bracket, factors of -12 that add up to +1, +4, and -3. Now I have two things multiplying together to equal 0. Either that thing equals 0 or that thing equals 0, and from there we can get our two solutions. Now I'm okay if you straight away go to x equals -4, x equals +3, but I want you to make sure that you understand what's happening in that process, because it's really dangerous if I give you this, x doesn't equal -5 and +4, and people that seem to learn these rules in these ways seem to, therefore don't have an understanding of what's happening, and they just go, oh, you just change the sign of the number in the bracket. But the 2 and the 3 are involved here as well. Okay, so it's really important that you understand what it is that you're actually doing. I also find sometimes people that try to do too much in their heads, especially with that more complicated example I just erased, it's very easy to make mistakes and, for example, get an answer of 2/3 when it should be 3/2 or whatever it might be. Okay, so I'd encourage you, even if you don't write down the line where it says x plus 4 equals 0 or x minus 3 equals 0, that still needs to be the thinking that's happening in your head in terms of how am I getting to x equals -4 and x equals +3. Okay, part F, again, looks like a non-monic, we've got 0 on one side, we're trying to factorize the other side. It looks like a non-monic quadratic, but there's a common factor of 2. Now we could factor out the 2 and leave it on the left-hand side, but again, because we've got the equation equal to 0, it's much easier to just divide both sides of the equation by 2. So we're dividing by 2, and then we can get rid of it. X squared plus 5x plus 6. But once again, we can only get rid of it because we've got two sides of the equation. We're doing the same thing to both sides. If there was no equals here and we were just factorizing, we would have to write it as 2 times x. Okay, but we've divided that away onto the other side of the equation, and so we now have x squared plus 5x plus 6 equals 0. Factorizing, it's a simple quadratic. Factors of +6 that add up to +5. X plus 2 x plus 3. Null factor law tells us that x plus 2 could equal 0, or x plus 3 could equal 0, which means that x could be negative 2 or negative 3. There's our two solutions. Okay, last two, part G. Make one side 0, already done. Factorize the other side so that we've got a product equaling 0. We're looking for common factors if possible, but there aren't any common factors in that left-hand side, and so it's a non-monic quadratic, and we'll need to use our non-monic method for factorization. So I'm doing 3 times 6 gives me 18, and I need factors of 18 that add up to 11. So I'm thinking about 9 and 2, positive 9 and positive 2 multiply to give positive 18, positive 9 and positive 2 add to give positive 11. Okay, so then you'll remember we break up the 11 by rewriting it. So 11x will no longer be 11x, it'll be plus 9x and plus 2x. And you can write those in the other way around, that's fine. You'll get a slightly different next line, but the final line will still be the same. Okay, so we're factorising by grouping. Common factors between 3x squared and 9x is 3x. And we're going to have x plus 3. Common factors between 2x plus 6 is plus 2. And we get x plus 3. And we know we're on the right track because our brackets are the same. So we take out the x plus 3, and that is being multiplied by 3x plus 2. Now you'll notice I haven't lost my equal to 0. Okay? We're writing equivalent equations here. This equation has to be exactly the same as that equation in terms of it gives the same solutions. This equation is the same as this equation. It gives the same solutions. This equation is the same as this one and this one and this one. They're all equivalent equations that give the same solutions. And they've got to be equations. If you haven't got an equation, there is no solution. It's as simple as that. X plus 3 times 3x plus 2, if you don't have an equal 0 here, there's no x equals anything. It's just an expression. If it equals 0, however, null factor law tells us that either x plus 3 is equal to 0 or 3x plus 2 is equal to 0. So this one gives us x equals negative 3, this is 3x equals negative 2, and so x equals negative 2/3. So that was what I was talking about before. Some students have difficulty rearranging that quickly in their head and will get 3 on 2 when it should be 2 on 3, or vice versa, or you'll lose the negative. So just solve it. You could do it in one step if you want, but just be clear about what you're doing. Okay, final example. Now remember, our first step is to make one side of the equation equal to 0. You might be tempted to go, oh look, I can factorise and I get 4x times x plus 2 and that equals 5. Equals 5, but that's useless. Knowing that two things multiply together to equal 5 doesn't tell you that they both equal 5. You can't say, for example, oh, that means 4x equals 5 or x plus 2 equals 5. If they both equaled 5, then multiplying them together wouldn't give you 5, it'd give you 25. Anyway, you want one side to equal 0. You need the null factor law. So we're going to subtract 5. 4x squared plus 8x, take away 5, equals 0. Okay, so then we've got our equal to 0 for our null factor law. We now want to factorise the left-hand side, so we can use the null factor law. It's a non-monic quadratic. There aren't any common factors. So 4 times negative 5 is negative 20. Factors of negative 20 that add up to positive 8. I'm thinking positive 10 and negative 2 will give me positive 8. So we're going to rewrite 8x as plus 10x minus 2x, or actually might write them in the other way, just so the factors are a bit nicer. Minus 2x and plus 10x, because I like the 2 with the 4 and the 10 with the 5 when I'm thinking about my next step here. So factorising by grouping, common factors are 2x, leaving me with x minus 1. Common factors in the second two terms are plus 5, leaving me with, what have I done here? Sorry, that shouldn't be x minus 1, it should be 2x minus 1. In the second two terms, common factor is 5, leaving me with 2x minus 1. Good, so my two brackets are the same. That's the common factor. Take out 2x minus 1 as a common factor, leaves me with 2x plus 5. Okay, so now my null factor law tells me the only way these two brackets will multiply together to equal 0 is if one or both of them are equal to 0. So 2x equals 1, x equals 1/2 is a possible solution, or 2x equals negative 5, x equals minus 5 on 2 is the other solution. Okay, so some practice using the null factor law is going to offer you good revision of your factorization processes as well. So exercise 5F is the work for today.